All right. Hello, everybody, and welcome to the stream. I hope everybody is doing well tonight. Tonight, we are going to kind of continue a little bit with the theme of last night, in that we are going to address a couple more performance things that I've kind of dug up and found. So that is kind of what's on the roster tonight, and then after we get through those things, we are also going to probably switch back to UI, right? Because we've made a bunch of changes. We need to actually merge all that into our standard UI feature branch and go from there. So before we really jump into everything, I want to take a quick second and just thank the supporters of the channel. And those are beginning with the partners over on YouTube memberships and Patreon. That is the top tier of support there. They are Aarcia, Garboles Inc., and Patrick Kuhlman. I'd also like to thank all of the other fine folks on the screen under the supporters section, who are the other tiers of support on Patreon, YouTube memberships, as well as Twitch subscriptions. Thank you all very much for your support. I greatly appreciate it. And of course, it goes without saying that I appreciate each and every one of you viewers here. Of course, without you guys, this project would not exist in the first place. So thank you guys very much for being here. I really appreciate it. So, with all that said, we are continuing our journey of creating a game engine from scratch here. And last night we addressed a few build issues, a few performance issues, as well as implementing our audio system, right? So we got all that stuff merged in, which is awesome. And tonight we're going to handle a couple more things that are going to push our performance a little bit further, right? Because it's something we haven't really paid too much attention to, and it's something that, could use a little bit of a boost, right? And so if we build currently right now on the main branch, go ahead and just do a quick build and run. All right. So if we go ahead and debug this, and I'm just going to pull this down here and run this. All right, and I'm going to pause the music for a second here. And if we go to full resolution here, without anything running or whatnot, without any level loaded or whatnot, if we turn off VSync, just to kind of get a baseline here, without anything rendering whatsoever except for this text and this one icon up here, we're only getting 113, 117 frames a second, right? Which isn't all that great, right? And so what the heck is taking all the time, right? Because this, we should definitely be faster than this, not rendering anything to the screen. And obviously if we render stuff to the screen, it gets even more insane, right? So, we get, maybe 70 frames a second, right? Which is better than what we had before, but still not ideal, right? And so what I'm thinking here is there's something that's majorly getting in our way. And I know what that thing is, and we're going to go through that now. So let's go ahead and close this down. And what I did was I went ahead and cranked up the old Intel VTune, right? And this is just to kind of get an idea of where all of our time is going. So basically what I did was if we take a look at this here, this whole graph is basically the entire runtime from start to finish, right? So if we examine this a little bit, let me zoom out. We can see here, this is sort of our startup phase. This is where we create all the job threads, right? Then we've got some dead space in here. We're really not doing too much. And then here is where I actually loaded stuff. So you can see these job threads working, right? And if we scroll that down, you'll kind of see that pattern kind of continues downward. The only other thing is we have these source work threads here for our audio. They don't do a whole hell of a lot right now. They're just kind of there. And so what we notice after this is we have a pretty regular CPU usage here, right? And so what I've done is I took a snapshot of this earlier, and I just let it run for a minute from the time that we have loading completed without VSync on, right? And so that gives us the full throttle, like render as many frames as you possibly can per second. And let's see how we do, right? And so we have a bunch of different ways of looking at this data, but I think that this one is probably the best and easiest to understand when we look at it, right? So this basically takes an average of all the time, or essentially all the time spent across the entire run of the application. So you'll notice that there's a bunch of engine create and stand-up stuff. This is all the stand-up stuff here, right? So that sort of cascades down. And then we have on a different thread over here, we have all of the SCBI loads, right? The image loads and stuff. This is something we obviously need to address as well. But then right here in the middle, engine run is actually what we are concerned about, right? So if we kind of zoom into that a little bit, we have our application render frame, which isn't actually occupying that much time. So given the application running for about 1 minute and 15 seconds, our application render frame took a total additive across the whole thing 1.667 seconds, right? Which that's pretty small considering it ran for 1.5 minutes. What didn't take a short amount of time is this render frame prepare, right? If we take a look at this, this took over 30 seconds out of the entire minute and a minute or so of runtime, right? And so that is pretty significant, right? The fact that our render frame prepare is taking so much more time than our actual render is crazy. And so, there's some things I kind of expect this with, like we haven't optimized our math yet. We haven't optimized a lot of different things. But it shouldn't be this far off, right? And so if we drill down a little bit, we have our Vulkan render frame prepare, and then we have our render buffer clear, and then we have our free list clear. And this is the bottom of the stack, right? And so our free list clear is where our actual bottleneck is, believe it or not. And the reason for that is, let's open the C file and go to clear. The reason for that, believe it or not, is this loop here, right? So the way that this free list works, just as a reminder, when we stand the free list up in our internal state, we also calculate sort of a max number of nodes in our internal linked list that our free list maintains. And essentially what we do is we have several places where we invalidate all of those nodes. So essentially that means that we go through each one of these entries. We set the offset and the size of that individual node to invalid ID, right? And this is actually a very expensive operation when you're talking a whole lot of nodes, right? And I don't, off the top of my head, know what the number of nodes is, but I know it's a lot of nodes, right? It's in the thousands, hundreds of thousands, if I recall correctly. And so looping over those things once a frame is actually very expensive, right? And so I started thinking about this, like how can we possibly improve the performance on this, just to kind of speed things up a little bit. And so phase one of this approach, what I did was I said, okay, well, we don't really need to set these things to invalid ID, right? There's a quicker way that we could do this. And that quicker way would be, what if instead of using invalid ID, we just counted the node is not used if its size is 0. And the important thing to note there is a size being 0, meaning we could zero out the entire structure, either one at a time, or if we're doing all of them, we could basically do a set memory to 0 on the entire array, which would be much faster than looping through each one and setting them in this fashion, right? And so that was kind of the first thing that I did, is I went through and did that, right? And so that actually gets us to this second result set here, which was a pretty significant improvement, right? So again, this ran for about 1 minute and 10, 15 seconds, something like that. Just keep that in mind, right? And now if we look at our render frame prepare, it's much closer to what our actual application render frame is. I think this ran for a little bit longer than the last one, right? So a render frame occupied 2.5 seconds out of 75 seconds, right? Which is still pretty small. our render frame prepare now occupies 6.7 seconds, right? So if we kind of put this into perspective, we did run this one for 10 seconds longer. So you'll have to kind of keep that in mind. These aren't exactly one-to-one. I should have probably timed it out a little bit better. But the fact that this ran longer and still represents a smaller amount of time is pretty significant, right? And so this guy in the last one was 30 seconds, right? So it was basically half of this entire runtime was spent doing this, right? Versus this one, which is 6.7 seconds out of 75 seconds, right? So that's a pretty significant improvement. And all we did was switch to just zeroing out that structure to invalidate it, right? So we're still doing it every frame. And what we're doing here is on free list clear, instead of looping through like that, we call K0 memory, which goes to platform 0 memory, which goes to memset under the hood. That's what this is, right? And so that's a great improvement, right? But it's still not quite enough, right? This is still a significant chunk of time that we're wasting here kind of doing this operation. And so this got me thinking a little bit more about what we could do further, right? And some of the other ways we're doing this in other parts of the engine. And I got thinking about our linear allocator that we use, our frame allocator, right? That since we're clearing this every single frame, right? Why couldn't we essentially make this act like the linear allocator does and essentially reset it, but not actually zero out the memory, right? How do we do that with a render buffer? Well, since we are using the staging buffer, which is what this is ultimately clearing, right? This is the staging buffer that we created. Since we're using this and wiping it out once per frame, we could literally do this in a linear fashion, just like we have for our frame allocator, and do that instead. And so what we do there is we'll do git checkout performance render buffers, right? So this is a branch that I sort of put some changes into. And this branch handles things a little bit differently. So instead of actually clearing our free list, or instead of actually doing anything with our free list, we actually don't use a free list at all, right? So we'll kind of go through the changes of this free list in a second. But what we want to look at is, let's see, we want the Vulkan backend. And we want the render buffer render buffer. Why is that not coming up? Am I in the wrong file? Render. Do I need to reopen this guy? Probably. Let's see, that's render begin. Oh, right. It's actually not at this point. It's in the front end. My apologies. It's in the renderer front end. I was like, where the heck is this function? So we'll look at render buffer. Let's do clear, right? So this is the one that's taking all the time here, right? Oops. Here, right? So render buffer clear is ultimately what is costing us all that time, right? We're doing it every frame. And so what we've done instead we've introduced this track type to the render buffer, right? And so our track type can either be none, free list, or linear. And so we've defined a new enumeration here for those things, right? And what we've essentially done is we said, okay, if we're using a free list and we clear it, call free list clear like we've been doing up to this point. Otherwise, if we have track type of track type linear, we have a new thing in here that's called offset, which basically maintains an offset every time we do an allocation. And we just reset that to 0. And that's the only thing that is actually done, right? And so if we look at our render buffer allocate, we now have a way to differentiate these two. So if our track type is none, then we basically say, we throw a warning about that. We're saying, hey, you're trying to allocate from a render buffer that doesn't use any sort of allocation. You should be using render buffer load range instead, right? But otherwise, if, let's see. We actually, we have a bug here, actually. So when we allocate this, we should not be allocating a block here. So we should actually, in this case, return true, right? And so basically, what we're going to do is we're going to say if we have a linear type of allocation routine here, or track type, right? We go ahead and we set the out offset to, whoops, that should be offset, right? So we set the offset there, and then we set the, wow, how did these get messed up? I don't remember them being wrong before. This is going to be offset. There we go. Okay. So what we do is we set the out offset value of that pointer to buffer offset, right? So that gets set first. And then we modify the buffer's offset to plus the size, right? And then we return true. If neither of these things is true, meaning our render buffer track is not type none and is not of type linear, then we do a free list allocate block, right? And that is basically what calls our logic for that, right? And then that works, kind of as we had before. The only other thing to point out is in our resize. Actually, I don't think we had to do anything in our resize. Nope, we didn't have to change anything in our resize other than looking at the new track type. When we create, we create a free list if needed, right? So if the render buffer track type is free list, we do the same thing we did before. Otherwise, if the track type is linear, then we just make sure this is set to 0, right? Obviously, when we destroy, we check that track type again. We say if it's a free list, destroy the free list, free the memory, etc. And then if we are using linear, we just make sure that's set to 0. And we're good, right? So there's not that much change in here, right? It's just really the interface and the calls to this, right? So if we go ahead and build this and go ahead and build that. TK Pending, thank you for the follow. I appreciate that. Welcome. So if we go ahead and build this, what we're going to see is actually a significant difference. And I actually profiled this earlier with this guy right here. And this is what our flame graph looks like here. And so we're looking at something significantly different here, right? Now all of a sudden our startup routine takes a lot of the time, right? Our image loading takes another bulk of the time. And we actually have to kind of drill down to even find the update, right? So we have render frame here, which takes 1.6 seconds, which is to be expected. This right here is our application update, right? So if we drill down into that guy, we actually have to sort of dig around to actually find it, right? So we have application updates. This is all the debug console here. This is the simple scene update. So this is all the updates associated with that. And in fact, I don't even see the reset in here at all. Maybe this is it. Transform position sets. Yeah, so see, I mean, it's such a small amount of time that it's literally not even showing up in here. Let's see. So here's the allocate and begin single use. Let's see. Copy buffer. Yeah, I'm not even sure where it actually is in here, right? Because all we're doing is literally setting a 0. So if we run this now, what we're going to see is a significant difference in frame rate. So we'll go ahead and kick this off. Right, and I'm gonna maximize this to 4K resolution. And we'll turn off VSync. And now look at that. That's quite a significant jump, right? So, that is the kind of stuff we're talking about, right? That's literally like probably a 5 or 6x improvement, right? And the other thing we did was we added a little bit of extra metrics here, right? So we now measure a few things separately. Before we had just sort of update and render. Now we have the update. We have the prepare frame, which is taking about a microsecond to run, right? Our update takes 80 microseconds to run. Our render is taking around 300 microseconds to run, a little more than that, right? So that's still like a third of a millisecond, right? And our presentation is taking about half a millisecond, right? And so if we look at this, our frame processing time is taking under a millisecond, right? And there are some other things that are happening outside the scope of the application, which accounts for the deficit between this time and this time here, right? So the engine is actually doing some things that we're not actually tracking yet. But yeah, significant improvement. So if we load this up, right, now we have a much better frame rate, right? It's still not perfect. We still have some things to do. We still have some work to do in terms of optimizing this further. But yeah, it's 130 frames a second now versus something much less, right? So that is that. Definitely an improvement in performance there. Feel free, Toffee. Thank you so much for the follow. I appreciate that. Welcome to the stream. I do want to indicate to you guys, any of you guys that are new to the stream, this is an interactive stream. So if you guys have questions or you want to comment, feel free to jump in and we can discuss it, right? I can answer it to the best of my ability. The whole point of this is it's supposed to be sort of a learning exercise and / discovery, right? And so if there's any of these things that you guys have questions on, feel free to ask. Okay. So, I actually made a couple of changes here. So let me just do a diff on this real quick. I think the only thing that we actually fixed was this. Okay. And let me just do my due diligence real quick and check the logs. Make sure we don't have too many errors. Looks like we got an OpenGL error there, so we might have to investigate that at some point. But those are the only things, right? We didn't get any Vulkan errors or anything like that. So that's cool. Now, one thing I would like to point out is, well, actually, let me finish my thought process here first. Let's go ahead and get this fixed. Render buffer, allocate bug. Right, so let's get this pushed up to the repo, and then we can actually look at the diff and see what all the changes are, and they're not significant at all, actually. At least not for the benefit that we got, right? So I'm going to refresh this. I created this pull request a few minutes ago. All right, and if we take a look at files changed, actually. So it looks like, actually, looks like we have a couple things that we need to address still. So this needs to actually go away because we shouldn't actually be doing that. We've got some dead code here. So basically we just commented out that for loop, although Yeah, so basically what we did was we removed this for loop in the free list and replaced it with a 0 memory, right? So we just hit the whole block at once. We did the same thing here. Looks like I've got some dead code to actually remove, so that's something I should do. Instead of using invalid ID here, we use 0. I could just call 0 memory on this, but it's only 3 variables, so that's simple enough. So let's go ahead and fix these real quick. Hey, Flavin, how's it going? Text to speech there, nice. Coffee Lava, thank you for the hydrate. Appreciate it. What's going on, dude? How's it going? All right. So yeah, let me update this real quick. So yeah, so we still have a few spots here where we're doing the invalid ID thing. Yeah, this is actually
TTS test, doing good. How about you?
TTS test. Yes, TTS is a thing, and I have some extra voices in there too. I'm doing pretty good. Doing pretty good. Can't complain. All right, so I think let's see. Let's just grab this. And I'll do the same thing here. And remove that. Let's get rid of that and that. So we're not looking for that anymore. Okay. All right. So we'll go ahead and just push this real quick. Removed dead code. All right, let's refresh this again. And I'm just going to squash these commits anyway, so it doesn't really matter, right? So this is a little easier to understand, right? So all of our loops where we are doing this, we're now just going to set that all to 0, right? And instead of checking for the invalid ID on an offset, we're just going to check a 0 size, and that's going to mean that the node is unused, right? So we've got the same change there, the same change here, and then here is where we actually check, right? So when we're getting a new free list node, we simply just check the size. If it's equal to 0, that means it's available. We do make sure to 0 out the next and the offset, right? Because our reset doesn't necessarily do that for us. Return node does, but if we reset the whole thing, it doesn't actually do that, right? And so return node also obviously sets those to 0 instead of invalid ID. So that right there is probably also a 3 to 4x improvement at least. So that is the free list. The renderer front end, the changes here are mostly interface level. So actually, let me hit the header file first. So we now have this new typedef enumeration here. So we have a track type of none, free list, and linear. And we basically use that throughout, right? So on the render buffer itself, we keep the track type and we keep an offset for linear tracking. It's the only thing it's used for. And then on the renderer front end, when we create the render buffer, instead of use free list as a Boolean, we have a render buffer track type that gets passed in now. So there will be a lot of changes to other files just to meet that interface, but this is a much better and much more extensible way of doing it, right? So we've got that. And all of our changes in renderer front end C basically are changing the implementation for that, right? So we take the trap type instead of use free list, and we save that off. Here we say if the track list is, or the track type is free list, then we go ahead and do the same thing we did before. Otherwise, we set 0 here, right? And then, let's see, a little further down, again, we check the track type within render buffer resize the free list if we need to. For resize, we don't actually have to do anything with a linear allocator, right? Because we're still going to occupy the same space and memory from the beginning of the buffer, so that doesn't have to change. We are going to have adds here in just a second, FYI, so I'll try and keep an eye on that. So when we're allocating, this is probably the biggest change. So if we have nothing as our type, right? Instead of looking at the free list memory requirement 0, we can now look at the track type and say if we don't have any tracking type, then we shouldn't be allocating, right? We should be using this load range instead. Otherwise, if we do have linear, we go ahead and we set the out offset to the current buffer's offset, and then update the buffer's offset, right? So we have adds. And we'll kind of continue this once we get back from adds. So for those of you that can still hear me, I do like to pause the stream for ads, so that way nobody that has ads currently running is actually missing content, right? So if you'll just stick around for another minute and a half, we'll get right back to it. So we got about 40 seconds remaining, and then we'll be right back to it. All right, we got about a few seconds left, and we can kind of jump back into it. All right, and we are back. So for those of you who weren't able to hear me during the ad break, I'd like to pause the stream just momentarily while ads are running, so that the folks that are being served ads don't miss any content, right? It's just something we like to do here on the channel, just to keep people from missing out on what I'm explaining that's on the screen at the moment, right? All right, so let's finish up the renderer front end. So basically the last bit of this in here is under render buffer free. We basically say that if the track type is not free list, we shouldn't be freeing, right? Because if we're not tracking it at all, that means we should be using load range. If we are tracking it, then that means we're either using a linear buffer, which only allocates from the front and keeps going. There's no way to free entries on that, right? It's not a stack, it's linear, right? So we wouldn't have a way of knowing how to reverse that, right? Or we couldn't even necessarily do it. And so the only one that can actually support the free operation is free list. So we're saying if it's not that, we're gonna warn about that, and then we'll go ahead and return true to say success, but nothing was really done, right? Otherwise, we go ahead and just call the normal free list free block. And then down here in render buffer clear, instead of, once again, looking at the memory requirement, we look at the track type to say, hey, if it's free list, clear the free list using the new code that we just put in. Otherwise, if it is of type linear, all we do is reset the offset to 0. That's it. We don't touch the actual buffer data whatsoever. We just overwrite it the next time we go ahead and use it, right? And so that's going to be extremely fast. as we saw in the metrics before, right? And so that is really all there is to the renderer front end changes, right? That's that. The rest of these changes are all going to be, I think, to match that new interface point, right? So wherever we create a render buffer, we just have to supply the track type, right? So basically anywhere that was false before is going to be used the track type none, where we should be loading range. And anything that is true is going to use the track type of linear allocator. And then we have one spot that's going to use our new track type linear. So these both are none. That's for the index and vertex buffer there. And then we also added some additional clocks in our game state. I'll come back to that. And in fact, I'm going to skip testbed main too, because that most of the changes here are actually regarding that. So I'm going to come back to that. So Vulkan backend also has a few different buffers, right? So we have a vertex and index buffer here. And so those both use free lists, right? And then we have the staging buffer that we created 2 streams ago, I think it was. And that guy is going to be a linear. So that's the one that's going to use our linear track type, right? And then the only other thing that I changed back here a little bit was our wait for fences. I actually moved, and the reason I did that is to say, okay, well we're gonna hold up this call until our in-flight fences for the current frame have actually finished work, right? And that basically means that the work that was submitted to the command buffer is complete. And the reason we're doing that is because this is technically part of the render timing, right? It does technically slow down our overall loop a little bit, but it's better that it adds it to this time as opposed to the present time, which would be inflated artificially if it were waiting on the rendering work to complete, right? So our render work completing is technically under this, right? We may come up with a better non-blocking way of doing this, but for now, that's how we're going to do it, right? This is hardly going to hold us up in terms of frame rate, at least not that much for now, right? The next thing is in our Vulkan renderer present, we actually adjusted this a little bit too. So we had this wait for fences here. That's been moved to here, right? So we've removed that just to make sure that this count is actually correct. And then I've got a little bit of a hack here. And we basically have to wait on the transfer queue. I haven't quite figured this issue out yet. But before we present, using the present queue, which is completely different, for some reason, if we don't do this, this call seg faults after the application's been running for a while. I haven't completely figured out why, but I did figure out that we need to wait until this queue is idle before actually calling this. And then it never happens. So I've got to do a little bit of digging to see what all is causing that. And we might do a little bit of that on stream. We'll see. Linux Cow, first time chat. Welcome to the stream. Hello. How are you doing? Welcome, welcome. Okay, so our other things here are, again, more interface changes. So we're creating some render buffers here for read and uniform, right? So our reads are basically track type none, because we're just using the whole thing. And then our uniform buffer is using a free list, right? So we've got that. And then we've got another read buffer here under buffer read. That's track type none as well, right? So not a whole heck of a lot going on here. We do need to investigate this issue. We'll try some stuff out and see if we can't figure that out. Okay. I'm pretty good, Linux Cow. Thank you for asking. Yeah, we're just looking at some performance tweaks that I made and kind of going through them and trying to understand them a little bit. All right. So when I was talking about the queue, we actually made some minor changes to our queues in general, just trying to sort of debug that previous issue that we had as well. So what we're essentially doing now is when we go to create our queue for our presentation, we're actually going to use a different queue for that. So before it was using the graphics queue. So the graphics queue and the present queue were the same if they shared a queue family. And now we're actually forcing those things to be split up into their own queues, which they probably should be anyway. And so what we've done is instead of having one priority, we're just sort of hard coding two priorities here. So this first one is going to be for graphics, and the second one is going to be for presentation. So we're going to say the presentation has a higher queue priority. Not that I think it matters. Although maybe it does. Maybe it does. Maybe I have to. Maybe that's the issue, right? And so when we're figuring out how many queues we need to create, we have some logic here that says if our presentation shares our graphics queues queue family, and the current index that we're on is the present queue family index, then we're going to increment that count to 2, right? And then use the queue priorities, right? So we're basically going to create 2 queues out of that same family if they're shared, right? Otherwise, that'll just sort of happen naturally anyway. And then down here, when we actually go to get the queue, instead of just hard coding a 0, we're going to say, okay, well, if we're in the same family that's shared between graphics and presentation, we're going to pull from the second index instead of the first to get a unique queue. So when we go to set our queue index here, as far as which one we want to grab, right, we're going to say, okay, well, if the graphics queue index is equal to the present queue index, then we're going to grab index 1. Otherwise, we're going to grab index 0, which will basically say, if this isn't true, then they're in separate queue families and we need to grab index 0. Essentially is what that's saying. So that is that. And the other changes here are mostly supporting some of the additional clock stuff that I added on the screen that we kind of saw earlier. So before we had an update clock and a render clock, but we had 2 more calls added to our application a while back. And so we're going to track those things separately. And so now we have a prepare clock, which is all of the stuff that's done to prepare our frame, any jobs or anything that's running, right? We're going to keep track of that. And then we have a separate presentation clock, right? Because that can actually add to our overall time, right? So the rendering is the actual queue submission and execution versus the presentation, which is actually just presenting the image, right? And so we track those things separately. Here is where we are actually standing up those clocks, right? So we're just doing that. And then we actually have right above where we're actually updating all of our text here, we're doing a little bit of running average keeping, right? So instead of updating this every frame and having a number that updates real fast and you can't ever read it, what we're going to do is we're going to basically update it once per second. And the way that we achieve that is we have an accumulator here for milliseconds. In each frame, we say, okay, how much time since the last frame? And that might be 60 if we're v-syncing, or it might be 800 frames per second. We don't know what that amount is, right? So we accumulate that, and whenever we reach 1,000 milliseconds, which is 1 second, then we go ahead and we perform some calculations based on those running numbers and get averages, right? So essentially what we have here is we have our total update, prepare, render, and present seconds. So that's for each one of those clocks. And then we also have some average values here, right, that we also keep. And all these things are static so that we don't have to sort of redeclare them or store them in state anywhere. We can just statically have them here, right? And so what we do is every single frame, we accumulate our milliseconds from the frame time. And then we take our seconds and update that based on the clock elapsed time for each one of these clocks, right? So we go ahead and add those together. And then once we've gone about 1 second, maybe a little bit over, right? Then we go ahead and we calculate an average for each, right? So we're accumulating the time up here every frame, right? And so we need to average that out, which means that we basically need to take that and divide it by 1,000, which actually we should probably be dividing that by accumulated milliseconds, instead. So let me fix that, because that's actually going to ever so slightly throw off our calculations. Right, so instead of this, it's going to be accumulated MS, right? So accumulated MS and accumulated MS, right? So like a lot of this stuff I haven't sort of re-looked at and re-reviewed, right? So I'm gonna find bugs along the way. Okay, keep it running average, and instead of the last 60 frames, we're gonna say the last around 1 second. Might as well update that too. Okay. So I'll push that here in a second. Actually, I'll push it now. Whoops. Fixed timing. Inaccuracy. All right. So we'll go back here. Taman, how's it going? Good to see you. Good evening. We are just looking over some additional instrumentation that I added kind of alongside of some performance updates, right? So we've got all of that. So basically take all these totals now and we jam them in here, right? So before we had this sort of state last update elapsed and render clock elapsed, and we were just converting that to microseconds, right? But now what we're doing is we're just taking the running averages that we have. So we have the update, prepare, render, and present averages, and we're just kind of putting those in here, right? And so what we've done is we kind of split this up a little bit. Like we have the timers all on one line now. So we have an update, a prepare, render, and presentation, and then we also have this total, which is here, the total average, which is all of them added together, right? And that gives us the total average running frame for the whole thing, right? So we put those in there, and we remove this extra text line here, and we actually bump the position up of this a little bit, right? And so in prepare frame, let me bump this up a little bit. So in application prepare frame, we start that new clock. We do all of our prepare frame stuff, which is quite a lot of lines, right? And then we go ahead and update that clock here. In application render frame, we actually made a little bit of a change here. So we essentially took, why are these dead lines in here? We probably shouldn't have those in here. We should probably change that too. But what we did was we essentially started the clock for rendering first and then do render begin, right? Because render begin is part of the render cycle. And then we were also ending the clock or updating the clock immediately after execute frame, right? And really it should have been after render or end, right? And so here we've moved that. And then we start the present clock immediately after that. And the present clock is only measuring the render present, and then it stops, right? So that's that. And then the UI text position set, we just bump this up by 20 pixels, right? And so that is all of the updates to the test bed. And that's all the updates in general. So let me flip back to this really quickly, and I'm just going to I'm actually just going to remove some more dead code here before we check this in. So where was that other stuff? I think it was Was that in? That was here. So we have the app frame data. We actually don't need this line anymore. So that was just making things kind of confusing. Actually, I think that's the only change. So we'll call that good for now. But if we build again and run, oops. Okay. So we've messed something up here. Okay, so it looks like somewhere along the way, what is it trying to... Interesting. So we're going to have to actually, do we have a call stack here? Not really. Okay. So let's have free list find block. There's possibly something that I broke, right? Free list. Here's that warning. So let's run this again. Let me actually clean and rebuild this real fast. Yeah, I'm doing pretty good. Actually, we have profiled it. We didn't use Valgrind. We actually used vtune, which is actually something that we are kind of going through to sort of nail down some performance issues that we are having. So one performance issue that we were having was, let's see, let me zoom back out, right? Was this massive free list clear operation, right? Intel CPU specific? No, I'm running an AMD actually. So yeah, it works. They both use the same instruction set basically, so this works on that, yeah. I doubt though that very much that this would run on a Mac. Could be wrong about that though. But yeah, vtune's pretty sweet. Okay, so let's run this. So obviously I broke something, right? So metrics initialize. Size of metric state. Just 280. Okay, that makes sense. Allocate aligned. It's no coincidence that it's in our free list, right? Oh, I'll bet I know what we did. Free list space. Let's rerun this. So our first node is going to be size 0. Which is wrong, actually. Why is the first node? Because that's the head, right? Which is the size is zeroed out on the head. I will bet. Oh, I think I know what it is. I think it's that K0 memory that I added. The one that I did here. Yep. So I basically created the head here and the head node, right? And I think my loop was actually probably starting from index 1. All but the first node. Yep. So this actually needs to be moved there. Okay. Let's try that again. So now the node actually has a size. Okay, so we should be good. I'm going to pause the music again here so that we can see this run. Turn VSync off. Yeah, now we're running like 900 frames a second, right? Which I still think we can get that faster. But I think that's a pretty significant improvement for now, right? So if we look at this, to handle everything is less than a millisecond right now with a blank screen and just this stuff, right? Which obviously we're not doing anything fancy here. So if I load this up, and I'm gonna have to move the camera so we can actually read that a little bit, right? So we are actually still under a millisecond. Am I reading this right? Yeah, it looks like we're still under a millisecond for this, right? Now we've got some other stuff in the engine that's actually taking a little bit longer, but we're actually under a millisecond for our frame time, which is pretty awesome, right? It looks like we're still getting 200 frames a second. So yeah, this definitely much faster. Tushant Verma, I hope I pronounced that correctly. First time chatter, hello, welcome, how are you? Welcome to the stream. I am good, thank you for asking. When do you judge it's a good time to start profiling a project like an engine? So I would say you should probably do it every once in a while at a minimum. It's actually long overdue for this project, I would say. And the reason I started really noticing it was because of, the terrain was just making it super, super chuggy, right? And I'm like, you know what? We need to actually spend some time with this and actually profile this and see if we can knock it down a little bit, right? Yeah, it's probably good to see how it scales as well, right? So more objects, emitters, etc., right? So we're going to keep adding features, right? We've got a few more major features to add, but the stuff that we've optimized within the last few videos has already given us huge performance boosts, right? Now, there's stuff that I can think of right off the top of my head that will obviously help with this. So if we take a look at this scene, right? And bear in mind, the frame rate is going to be a hell of a lot better at this resolution, right? If I turn off VSync here, I mean, we're getting 400 frames a second, right? So when I have this maximized on my screen, this is at 4K resolution that we're getting that frame rate, right? And so there are other optimizations we need to look into. Like, we need to chunk up this terrain, right? Right now it's a huge mesh, like just one big mesh. And this should be cut up into a bunch of little meshes that we only render when they're in the view for sim, right? We should also have LOD, where we don't render as many polygons further off in the distance. That's another thing. That not only applies to terrain, but that also should apply to things like this car, right? Or everything inside this Sponza object, right? Speaking of the Sponza object, if we are inside this building, there's no reason to be rendering stuff outside the building, right? So we should have some sort of occlusion volume where we can say, anything that's inside of this, either render it or don't render it, depending on what our occlusion's doing. And we can use that to sort of optimize further, so that when we're inside of a building, we're not rendering all the crap outside. I don't have any LOD whatsoever. Nope. There's been no optimization behind that whatsoever. Yeah. So, considering that, it actually is a decent frame rate. Yeah. There's other things that we need to do to optimize for sure, right? We've been pretty focused on just getting features in. We haven't done a lot of optimization yet, so. Compute-based occlusion and frustum culling. That is something I want to experiment with, but I kind of want to do it the traditional way first, right? Because bear in mind, if we wind up doing I mean, I guess on OpenGL we could hack something together too. Eventually, yeah. We don't really have compute shader support yet. It's one thing I need to add, right? Because doing things like the terrain using compute shaders would be a lot better, for example. We may wind up using that when we do particles. Missed the stream in which you did mip mapping. Did you do it on the CPU? Nope. I used Vulkan for it. So that's using the graphics queue to do that. So yeah, that's all Vulkan stuff. We did all of it in Vulkan. Now, we are also eventually, and this is something that's on the roadmap, it's something that we can actually bring up here, right? This is the latest profile of the engine, right? Let me zoom out. Right, so this is the latest profile. Then we can see here, when we run for, was it almost like a minute, almost a minute and a half. This is basically total time taken across that minute and a half, right? And one of the biggest things right here is actually texture loading, right? It's taken a huge amount of time to load textures. And so we need to actually implement a, we need to implement a binary format for textures that we can write to and just read in quickly, basically, as is, instead of having to go through, a PNG or a JPEG parsing and that kind of stuff. And when we do that, we can also build in MIP mapping directly into that texture format. And then when we load it up, we can just load up the texture and the MIP maps all in one shot, and not have to generate them, right? But we want to be able to support both because our engine is going to want to take in raw textures and build that binary format from that, right? So we need to be able to actually do both. Let's see. Recently I heard about being better to calculate MIPS on the CPU because there isn't a nice way to do block compression on the GPU itself. Yeah, so compression would need to be done beforehand. Yep, that's true. And you need to do MIPS before block compressing. Yeah. So the thing about that is like I said, when we have a binary format, we will be doing it on the CPU. Or theoretically, we could do it on the GPU and then pull it back out. I don't know if that would be faster or not. We can play around with a few things there and see what works. With that, do I plan to implement something like G-deflate? I'll be honest with you, I'm going to have to look that up because I don't fully remember what that is off the top of my head. I assume... Oh, it's a stream format. Okay. Yeah. Yeah, I mean, we are going to do asset streaming at some point. So yeah, I would say yes. I haven't really thought too deeply on how I'm going to do that just yet, but GPU decompression, yeah. I haven't thought too deeply on that yet, but yeah. Obviously, there's going to be a lot of bandwidth optimizations that we're going to be doing as time continues, for sure. But the important thing to remember is you can't really optimize what you don't have. So, we have a lot of work to do before we can actually get to that point of being able to, write optimizations like that. But yeah, no big deal. Those are all valid questions, right? Certainly things we want to address. Did I have any pending changes here? I did have a couple things that I had to fix. So last thing fixed. free list bug. Right. So we get that pushed up, and then in our pull request, that should be all good. I'm just going to reread this diff really quickly. I think we should be good though. Okay, and all this stuff should be fine. Okay, so we'll go ahead and merge this. Come on. Into main. Nuke that branch. And repull those updates, and we're good to go. All right, so I think that's all the performance level stuff I wanted to cover for tonight anyways. Obviously, performance is going to be something that we're going to hit multiple times. I am thinking that I want to tackle the terrain chunking sooner rather than later, but I don't think I want to tackle that tonight. So what I am going to do, though, is go to our other branch, which is standard UI. Let me check. Do we have anything there? Nope. Okay, get merge main. Sweet. Merge conflicts, my favorite. I eat merge conflicts for breakfast. All right. I am not going to try and do those in Vim because the conflict editor here is a little bit better. It's just quicker. All right. What is this bleating about? Oh, right. So this actually needs both of these changes because our testbed lib now uses, let's see, do we want current change or incoming change? I'm going to do this on the current, I think. I'm going to take this and move it up here. So that's to include our standard UI and the OpenGL plugin that we added. And then this is going to be the same thing here. I wasn't thinking that there were going to be that many conflicts, but apparently so. So that's the batch file, which means the shell script is also going to have these. Okay, so here is the, I think in this one I'm actually going to do the incoming change. Oh, actually we need both. We need both of these. So I guess we'll build standard UI and then OpenGL. It doesn't really matter. What we're going to have to do, though, is we're going to have to copy over actually it should just be this, yeah. So that if we error out here, we don't continue. So that should be fine. This one is the testbed lib. So again, this is going to be the same issue as before with the other file. So I'll do the current change on this one. So we need this, include directories, and then link flags. Right, and we'll take current. Okay. And then testbed itself. I think it just needs to link with this guy, and that should be it. Start with something light and easy. Physics. That is on the list, actually. I'm sort of in a research phase on that to figure out how I want to actually tackle that, because that is lightweight. You're a funny guy. Lightweight. Yeah, about that. Okay, so K-memory. Oh, we've added UI and audio. So I'm going to take both and put UI first and then audio afterwards. And then we're going to have to go to the header file and do the same thing, which they should be in the same order. So we need both. We have ads. Rude. So I'll just turn the music back on when we get ads here. So we're just taking a quick ad break for those of you that can hear me. We just pause the stream for a minute until the ads finish rolling. That way that anybody that is watching that is being served ads right now doesn't miss any content. Got about 30 seconds left. Imagine getting ads couldn't be me. All right. So, question is, how hard would it be to start doing SIMD right now since the topic is optimizations? SIMD is actually one of those things that I want to spend a lot of time to explain how it works, and how to do it properly, right? And I don't think we're going to be able to fit that into this stream. So I do want to do SIMD. That is on the roadmap already. I can bump that up in priority since there's a couple of you asking about it. So I will make a note of that, because that's definitely something I want to do at a minimum in our math library, right? It's just not something I think I could probably cover tonight and still actually have time to like go through it properly, right? Because I don't really want to rush that. All right, last merge conflict. We have test panel and button from the UI controls, and then we have these audio files and test emitter. So we actually need both of these guys again. I'm just going to split those up. And I think we should be good. So I'm going to do a clean and a rebuild. Okay. Got something undefined. UI pass destroy, UI pass execute. Oh, I'll bet we're missing. Yep, we're missing K APIs on that. So we're not exporting these guys. which now is caught on this platform as well. We added that in the last stream. So we actually have that working, which is good. Verified. All right, built successfully. So since we have audio, I'm going to pause the music again. And we will run and see what we get. We should be good to go, but it should basically have everything that we're doing so far. Okay, so let me turn off VSync. Right, see our button is still doing the thing that it needs to do, which is good. I think one of the first things we're actually going to implement, by the way, with our buttons and our controls is volume control with the audio system. That would be a nice thing to be able to control. Cindy's nuts, I'm so sorry. That's a good one. That's a pretty good one. I like that. Leaker errors always make me so sad. They're not that bad. Right? If it's undefined symbol, there's only a few things it could be. It means either you didn't export, or it means that something is static that shouldn't be in the compilation unit, making it private, or it's just not defined. Right? Generally speaking, linker errors aren't generally too bad. All right, let me load up the scene. Let's just make sure that all this stuff works, kind of as we expect. And it looks like it does, right? So we've got all these things doing the thing. All right. So I think we're good on that. So this is all the stuff that we've merged into this branch, which is quite a lot. Merged from main. Cool. So now at least our feature branch is up to date. So, I think what we'll do tonight is we'll kind of get back to some UI stuff for now. So one thing that I was looking at before, let me load up the GIMP. Let's see. One thing that I was thinking about before was potentially having different like hover button states. Oh, you know what? I think I was working on this on my Mac and I actually forgot to push updates. Like a noob. Let me see. I think I was actually doing some work on this on one of my machines and I didn't actually push it, which is kind of terrible of me. But if that's what happened, we can fix that real quick. Yeah, that's exactly what happened. So give me just a second here to just going to pull the latest code. All right. And I'll pull down my updates. All right, so we've just done a few things here. Let me reload this image. Okay. Not a huge update, but not something I necessarily wanted to redo. Okay, so if we think back to a couple streams ago when we were implementing the buttons, right? This is essentially our button here, right? So this is our normal state, this guy here. I don't know if you guys can see where I'm actually pointing. Let me see if I can find a better tool to, I guess, here, right? So this guy, actually, you know what? I'm just going to paint some lines so you guys can see this. I'll use hot pink. Right, so, whoops. So this guy is our normal state, right? And then we have a pushed state, which is this guy. It's a terrible arrow, but you guys get the point. And then we have a hover state, which is this guy. And then we have a disabled state, which is this guy, right? And so these are different states that a lot of our controls are going to have. And so we kind of need a different graphical state for each one of these things. So if we look at this one, it looks like it's kind of pushed in. If we look at this one, it's the same as normal, but it's a little bit brighter. So when we hover over it, it should kind of light up a little bit, but not too much, right? And then disabled is sort of the same as normal again, except the outside border there is gray instead of black. And so the whole thing looks a little bit more subdued. And then we'll probably change like text color on that as well. And so these new states are actually what we kind of need to put in place. So with that, let's see, we modified kmath. Right, so if we go to, actually I think it was, yeah, it was the header file. Okay. All the way to the bottom, we have this contains point check, right? And so this basically takes a rectangle 2D and a vector 2 point, and then just does a check to see if it's within that, right? And so we kind of had this written out manually before, and this is kind of, we've kind of moved that to a function, right? Was I on the team that made World of Warcraft? No. That would have been cool, but no, I wish. The original World of Warcraft, anyway. Also, welcome, Turkey, to chat into the stream. First time chat, so welcome. The way Windows set up their code base makes it really easy to have a very difficult to find linker errors. Yeah, that's true. That's true if you don't link with the right library. Although, I don't know. I feel like with linker errors, generally speaking, once you've seen them, and you always kind of know what the various causes could be. Like, there's generally not too much mystery to it. Standard UI. I went ahead and made a couple of changes because I got thinking about this, and we needed to make a few small changes to the way that we're doing things. And so we've gone ahead and changed things to use floats instead of integers. And I was thinking initially that UI elements should be snapped to pixels, but we can actually use, floor methods or ceiling methods to sort of round those off and snap them to integers, if you will, if we really want to do that. But it was causing other weird things in terms of interpolation and things like that I really didn't like. So we're actually going to use floats for sizing and things like that. So we're using a rect 2D for bounds now. And then if we look at the actual implementation of this, let's see, where was that? We've got some other things here I'll come back to in just a second. Let's go all the way to the bottom, actually. So, here we go. Our button internal data looks a little bit different now. we do have in our 9 slice, maybe I didn't make it all the way through this. I thought I had. So we have the size. I think I was in the middle of converting it and never actually finished. I think that's what it is. Okay, so there's our click handler. We've already gone over that. Yeah, that's what it was. I was in the middle of changing it and hadn't actually finished changing it yet. So our bounds here, our bounds check against the transformed event, we can now actually, instead of having this big ugly thing, we can actually use this guy, rect2d contains point, right? So we can kind of, we can say here if rect2d contains point, right? And the rectangle is going to be control bounds, right? And then the point is just going to be, we'll just do this for now. We'll say transformed event dot x, transformed event dot y, right? And then we'll have that, and then we'll remove those 2 lines and that line, and that's a lot cleaner, right? We still probably ought to have a simple way to convert this from like a vector 3 to a vector 2, but I think for now this is fine. The next thing that I started implementing was the hover logic. So basically we're capturing the move event now and using that move event to say, hey, are we actually containing the point? And if we are, then we check to see if the control is currently hovered. So that's a new property that we have. Let's see, control. Here, right? So we have is hovered, which is probably going to be replaced by flags or something because we've got 3 booleans there and I'm not a huge fan of that. But we're looking at the hovered state now. And within the hovered state, we're saying, okay, if it was, if the rect2d contains point and it's not currently being hovered, then we want to say, okay, well now it is being hovered and call the mouse on mouse over handler that we've added. We should probably also check to make sure that exists. So if control on mouse hover, that should be that. So if we have that, then we should be doing that. Oops, that should be over. All right. Maybe. Yeah, we're already checking. So we're checking for the existence of either one of these things. We probably need to check it again here. I guess that's not too big of a check, right? All right, so we can say if control on mouse out, right? So if we are not hovering, then we say, okay, now we are hovering, and we call the on over callback. If we are not inside the bounds, and we currently are hovering, then we say, okay, we're no longer hovering, and call the mouse out, right? So that should go ahead and take care of that. And then we just need to hook up events for that on the button control itself. So I don't think we actually have anything on there just yet. So I guess let's go to the header file. System H. And we'll add a couple more things. Actually, I'm just going to copy from these guys. Oh, right. These should not be defined here. These should definitely be defined in the application. Or should they? Let me think about this for a second. So there's actually two functions that we need to happen here. The one is sort of a standard UI thing that needs to always happen, which is the standard hover logic, which would be us changing up that 9 slice to change what's displayed. And then the other potential is that the user code might actually need to do something as well. So we technically need to support both in this case. So I think that's what we're going to go ahead and do. All right. Kindred Games with a raid of 38. Thank you so much. I appreciate that raid. How are you doing tonight? Welcome. Welcome, raiders. So we are... first of all, my name is Travis. I've been developing a game engine from scratch here from about the last 2.5 years. It's all written in C using Vulkan as our backend. And everything here, with the exception of a few small utility libraries, is written from scratch. Those utility libraries are within the engine code itself. We have stbimage and stbTrueType, and then we're also using something to load up audio files as well. And we're using OpenGL, right? And technically we're using Vulkan, right? But other than that, everything here has been written from scratch. So we are in the process of developing all of this from scratch. And so I will drop a link here to our main webpage that details sort of what the whole project is about. It's kohiengine.com. So Kohi is the name of the game engine, and we're building the whole thing on camera, right? So it started off as a YouTube tutorial series and became a Twitch live stream. And basically what happened is this whole thing is sort of a giant educational exercise / experiment. So we're trying things out. We are seeing what works, what doesn't work. We've had a lot of successes. We've had a few failures. That's the reality of what happens in any large project. And so we're doing all of this on camera to sort of expose that process to anybody who watches, right? The whole thing is open source, so all the code is available here on GitHub. It is Apache 2.0 license, which basically says if you use the code, just credit me. That's it. But yeah, it's 100% free, no royalties, no charges for any of it ever. I purely am supported by patrons and YouTube members and things like that. But I don't charge for any of this. It's all 100% free. Everything on the YouTube and the YouTube channel and the Twitch channel are 100% free. Always will be, not changing that. We do have a Discord server as well with about, I think we recently hit 700 people on there, or we're about to hit it. So yeah, I hope that you guys find this interesting at least, right? So a couple things that we do have automated documentation generated as well. So you can actually see all of the, all the generated documentation for all of our different structures and things like that, right? So I think that pretty much covers all of it. Let me go ahead and give a shout out to Kindred Games. Definitely follow them. Let me see if I can remember how to do this. Did I do it right? Yes, I did. All right, awesome. So yeah, thank you again so much for the raid. How are you doing tonight? What are you working on? And thank you for the follow, by the way, Kindred and Zafra. Hey, I learned C. What else do I need before jumping on? So I would say probably some sort of basic understanding of graphics programming would help a lot. I try to explain a lot of the concepts as I go. Like I said, this actually started as a YouTube series. And so I do try to explain a lot of the concepts as we go. So we have a playlist here of 146 videos where we kind of go into how we're going to set it up from the very beginning, bootstrapping it, all that stuff. So we do kind of go through it, but since we are developing an entire engine and not just a renderer, there are parts that I kind of have to gloss over a little bit just to kind of keep things moving. But if you understand C and you don't understand Vulkan that much, some of the Vulkan parts might be a little bit challenging for you, but I think it's definitely doable, especially if you're able to pull the recent examples and kind of look through the source code that we have here on GitHub. You should be able to, I think, pick up and run with it. Let's see. What languages does this work in progress game engine support? So the answer to that would be C. So do you mean like in terms of like scripting languages or something like that? Kindred was working on some level design. Awesome. I love level design. I actually can't wait to do more of it. We are sort of scaffolding a UI system right now to build an editor. I can't speak tonight apparently. And so the UI system is obviously paramount, and we're building that from scratch too. We're not using any libraries for that, right? So we're building a UI library right now to get some basic functionality in, so we can start standing up an editor. Let me see if this even actually builds. It might not. Let me see. Unused function. I might be able to get around that one. Let me see if I can get this to build real quickly so we can actually look at what I'm doing. So I think if I shut that one off. Maybe it'll build. So let me actually see if I can get this to run real quick, because I was in the middle of taking things apart, but I might have not taken it apart enough where it's going to completely break everything. Okay, so in terms of what we do have, right? Now this obviously is not very impressive to look at, right? Because we haven't loaded a scene. So what you're looking at is basically just a blank screen with a few UI things that we're kind of messing around with. This is our testbed application that we use to sort of test things as we're building it, right? So if I press L on my keyboard to load up a scene, we actually have a scene that loads up with just some test models and test terrain, right? Nothing crazy, but we do have a grid available here. We can do raycasts into the scene, right? And we can use that to pick an object, right? And then we can actually take that object and move it around in the world using our gizmo, which we also built from scratch. And so, we can rotate and all the good things, right? We can scale. Let me see. So I can uniformly scale, right? And so we have, some basic things that you might need if you're considering an editor, right? We have some basic things in and working. The other thing, as you can hear, is we have music playing, and we also have spatial audio. So we also have an audio emitter that's actually hooked to the same box that this light is moving back and forth. And so if you listen closely, there's basically a fire sound. And it goes back and forth between the different sides, right? So there's that. And yeah, so this is kind of what we're working on so far. There's not a lot of optimizations in place yet, right? So our frame rate right now it's V-synced. If I turn off V-sync, we get 150 frames a second or so. If we look up at the sky, that number jumps, obviously. And then we also have some button inputs working. So if I click on this button, even though it's being resized, I can click on it. Even though it's at an angle, I can click on it. And if I click here, I'm not actually hitting the button until we actually click on it, right? So that's kind of where we're at the moment. Kohi is 3D. Yep, it's a fully 3D engine. From Pakistan, awesome. Well, welcome. Want to learn game development? What are your suggestions? Okay. Are we back? I think we should be streaming. Not sure what happened there. We are back. Okay, awesome. I'm sorry about that, guys. Yeah, for some reason, OBS just completely froze on me. That's the second time it's done that, actually, in the last couple weeks. So I'm going to have to look and see what's going on there. Okay, yeah, sorry about that. So I'll back up a little bit. So yes, Kohi is a 3D game engine. I probably should have mentioned that from the beginning. But yeah, it is a fully 3D engine, and it doesn't mean that it's limited to making 3D games. In fact, the first game we're going to make is probably going to be a 2D game. I've already got some designs in place for that in terms of what we're going to build with it. We're missing a couple things like physics, right? We don't have that yet. But I think in terms of what we're going to accomplish with our first game, I think that's okay, right? Physics is kind of one of those things that's like a huge to-do, right? So just not having those right off the bat, I think is okay, right? Because that's going to take us quite a while, just like the UI is going to take us a little bit to get stood up, right? Okay. All right, so 0309. I'm not sure what you're asking me, by the way. I'm not sure if the stream died before I got a chance to answer you, but if you could clarify what you're asking there. Okay, so yeah, so basically what we're working on right now is we are working on our UI system, right? And specifically, we're working on the hover state, right? So we have the click state working already. The hover state is what we're actually wanting to put in now. So let's see. We have system click being handled, but we don't have system move being handled. So system click. So all we need to do is basically hook this up this way, move, and move. Just before I forget to actually do that. So also to kind of circle back to what one of the questions was before, is to, where you can actually start. I tried to make this as beginner friendly as possible, which I know starting with Vulkan probably doesn't seem that way. But the thing that I like about Vulkan is that it really forces you to sort of understand what the hardware is actually doing under the hood. Whereas OpenGL kind of masks that. OpenGL can kind of be a little bit better in terms of it's simpler to sort of get something up and running. But I think in the long run, Vulkan is definitely going to be better in terms of really having control and understanding what the heck is going on under the hood, right? So, yeah, I would definitely encourage you to take a look at the playlist that I have there on YouTube and sort of just skim through it and kind of get a feel for how the series goes. We jump around a lot, and just because we've written one system at one point doesn't mean that we're not ever going to revisit that, right? There are systems that we've revisited multiple times, and that's okay. We actually just recently introduced audio within the last week, right? Like I literally merged it into main last night. So our audio engine is brand new. So we're constantly making strides here, right? Okay. So I'm going to export these guys. And I'm going to call them SUI button on mouse out and SUI button on mouse over. And these are going to handle like the more generic type of stuff that you would expect a button to handle. Like when you hover over a button, for example, it should kind of light up a little bit. Or when you mouse out, it should kind of go back to its normal state, that kind of thing. And so we're going to have that, but then you're also going to have the ability to assign a callback from the user code to additionally do things. So we'll go here to the bottom and we'll put these guys in here, get rid of these exports. And then we don't really have a base function for this yet. We might eventually, but for right now, I don't think I'm going to bother with that too much. I think the only thing that we're going to do basically is update our 9 slice to render a different portion of the image on mouse out and mouse over. Fresh audio bits right out of the oven and into your ears, exactly. Is this like an immediate mode GUI? No, this is more like retain mode that we're doing. I thought about doing an immediate mode, but there's already a library that out there that does that, right? And it does it pretty well. I suppose we could roll one from scratch. I should mention, this is not the only UI system we're going to implement with this engine. So different UI implementations or different UIs for different applications have different requirements, right? Your UI requirements for an editor are far different than your in-game requirements for a UI, right? Like your health bars or your generic menus or whatever. Those two systems are vastly different in how they operate, what data they need, and just in general how they work and how they should be structured, right? So this standard UI is one implementation that we're doing, and this is what the editor is going to use. And it's going to provide all your standard controls that you would think of with a UI, your typical UI system. Your buttons, your panels, your radio buttons, basically all the stuff that we've started putting together in here, right? So we have this sort of image array with our checkboxes, radio buttons, scroll bars, things like that. That's all going to be supported in the standard UI. And a game could use this, for example, right? This is actually a plugin that a game or application can use. It's optional, right? I should actually mention that to the newcomers as well. So the way that this engine is architected is we're using a lot of things via plugins. So the engine kind of comes with a core set of functions, like our math functions, all of our memory functions, things like that. Some of our basic systems for loading textures and things like that. Things that every application that deals with a game engine is going to need. But then we have a couple of things that are actually standalone plugins that you can optionally add, right? So the renderer is one such plugin. So we have a Vulkan renderer right here. This Vulkan renderer is a plugin. And so the reason that we went with this architecture is, oh, you know what? We have ads. Bad timing on the ads. I'm going to pause the stream for a minute for the ads, and then we'll come back. So let me just turn the music back on just so that it's not like dead audio, right? So for those of you that can still hear me, whenever ads come up, Twitch gives me a timer for ads. Whenever ads come up, I like to pause the stream just for a little bit until those ads are finished running. So people in different locales, different regions, different platforms. Yeah, that's why I paused the stream, because I got cut off, right? So yeah, depending on your region, what platform you're on, you might get served some ads, all the ads, or no ads at all. And so there is a disparity there, but the ads they're either there or they're not. So I don't know who's getting which ads. I only know that ads are being served for like 2 minutes, right? So, all right. Epic cliffhanger. Yep. All right, so I think ads should be over. We should be good to go. I just want to make sure real quick because the stream died earlier. Can you guys hear me okay? Then we'll kind of continue where we were left off. So I want to make sure you guys can hear me first. Cool. All right. So the reason that we went this way is because the engine doesn't need to know what renderer we're using. It doesn't need to know that we're using Vulkan, for example. It doesn't need to know whether we're using Vulkan or DirectX, OpenGL, Metal, who cares, right? The engine shouldn't care about that thing, that kind of stuff, right? So we already have that level of abstraction needed. We have a renderer front end that interfaces with the engine. And then we have what's called a renderer back end, which is sort of the rendering API that you would think of, which would be your Vulkan, your whatever, right? And so we have this as a plugin because it allows us to be able to swap those out on the fly, right? So if we have an application that we say, you know what, we're only going to target Max for this. We're just going to use a Metal renderer plugin, right? And then that's going to be it, right? You can do that. If you want to use Vulkan or you want to use DirectX, you can do different builds with different plugins. You can swap them out, and you can choose in configuration which one you actually want to load up, right? And it's up to the application what plugins it wants to use. So the engine doesn't say, here's a list of plugins that you have, right? The engine just says, hey, I know you're using some renderer. You have to tell me what plugin you're using. And then it just interfaces through that plugin. So the application is going to be fully aware of its requirements and what plugins it needs to load and utilize. And so we only have the Vulkan renderer right now, but eventually we'll have others. And the application can go, hey, I'm running on Windows. Let's use DirectX. Hey, I'm running on Linux like I am right now. Let's use Vulkan, right? And so the application has the power to determine what plugins get used where. Same goes for the audio, right? So our audio system also uses a plugin. In this case, we have OpenAL as our plugin, but maybe we want to use Direct Sound or some other library like Fmod or something like that. We can have different plugins for that, and then the application can say, hey, I want to use this audio plugin instead of this one. And we have that power to be able to do that, and that power is all given to the application. The engine doesn't know or care about any of it. It just knows that something is going to exist. And so the standard UI is very much in the same way, where the standard UI could be either used by an application or not. So maybe our editor application, which is going to use our engine, will use the standard UI. But maybe a game that we make uses its own UI and doesn't need the standard UI. And so it simply just doesn't include it, right? So I hope that makes sense in terms of, what the reasoning is behind that and how all that works, at least on the surface, right? If you want to see the details on how that's implemented, obviously you'll have to watch the videos where we put that into place. But that's the long and short of it, I guess you could say. Okay. So, before I jump back into this, I don't know if I mentioned this also, but I do like to keep this stream interactive. So, if you guys have any questions like that, keep them coming. I don't mind, stopping and explaining something, or having a conversation. I like having conversations with you guys. So, feel free to jump in and ask a question if you have it. Don't be afraid, and I'll answer it to the best of my ability. And if I don't know, I'm not afraid to say I don't know. Right? There's plenty of stuff that I don't know about. So. All right. What's your line of codes looking at? Like total lines of code? God, I have no idea. I haven't actually. I don't even know how to count that actually. I'm minimum. It's in the tens of thousands. Yeah, I doubt we've hit 100,000 lines of code yet, but maybe. I kind of doubt it. But at a minimum, we're in the tens of thousands for sure. Because I know, like, the Vulkan backend itself is a few thousand lines of code. If that's what you're asking. So if not self, return. This is an event handler. So if we don't have self, I'm going to return false and say the event's not handled. And I'm also going to return a false down here. No, I'm going to return true. Never mind. We'll say we handled the event at that point. And I'm just going to copy this and put it here. So, let's do the mouse over first. All right, because we actually need to modify a few things on that. So, we have the SUI control, so we need to get the typed data, which is going to be just this guy here. And then within that, we're going to say type data. And let's go to our N slice. That's our 9 slice. And really what we need to do is adjust our Atlas pixels min and max, right? So that's going to be basically this upper corner and the lower corner, right? And so for hover, we're actually going to want this one, which is, let's see, 151.30 and 157.36. So 151.30, and the other one was what? 157.36. 157.36. All right, so let me just fill this out real quick. Yeah, so I guess I can just fill it out and just do it this way. So what equals that, and then set this to 30. Let's see. My auto mod, for some reason, banned the term little tool when you were talking about, like, a little tool called clock. Yeah, and for some reason thought little tool was bad. That's funny. Okay. I just want to share this because I'm happy. Finally got my ECS to work. Nice. After a long time. Next up is doing an execution graph. Sweet. That's awesome. Are you using macros for anything other than function decal variation? Yeah, there's a couple things. I use it in our dynamic arrays for a couple things. I have some logging code that is using macros. But yeah, I don't make extensive use of them, but yeah, we have them. I use them for some constant values as well. Welcome, by the way, first time chat, Tazdish. What made the auto mods unhappy? Yeah, it was little tool that made it unhappy. Yeah, auto mods, what a dirty mind you have. They really do. It's pretty funny. Deeply funny, actually. Okay. So let's copy pasta this. So we'll change this to max. And this is going to be 157 and 36. And I think that's right. We'll have to determine if that's right or not. And then I think the only other thing that we have to do is update. Let me see. So this is the panel. Generate non-slice. Didn't we have a call to... Yeah, here we go. We need this guy. Self-bounds, we don't need to change the bounds. So I think it's literally just a call to this down here. And I think that's going to give us our hover state. Let me see what the original values were. So the other thing was we're going to basically undo this, right? So we're going to put this here. And this was 12. And oh, this is 158, which means this one's probably 158. And then 19. I don't know if my pixels are exactly correct here, but we'll see. So the next thing we need to do is just tie these two in, and then we should have hovering working in theory. So here where we're doing the on mouse over check, we're actually going to we're going to do this. So this is mouse out. We'll say control and EVT. And over control EVT. And so what this gives us is our basic functionality comes first, and then if the user overrides it with their own callback, we then have that. So let me see what we get. So make sure I did all this right. I think it's right. Let's run and see. Bring this down here. There's a high possibility I got these wrong. It looks like I did. Okay. That actually doesn't seem to be working at all, which is nice. One thing I'm going to do real quick is I'm actually going to turn the music off. So let's see. We can load it up, that's fine. We're just not going to play it. That way we can actually not have that running every time we run this. So, mouse UI system move might actually not be often enough as a check. But let's go ahead and put some debug code in here anyways. So we'll say k debug. Actually, we'll do trace. And we'll say so we'll say button hover, and we'll put, I guess, the name of the button. Let's see if we even get... Yeah, so there's obviously something not getting hit there. So let's go to... Let's debug this, and let's see if this is even getting hit whatsoever, right? It's not. Sweet. Standard UI system move is not even being called. So that's neat. Let's see if we can figure out why. Standard UI system, click and move. So we're registered. Oh. Copy pasta. Yeah, I just have this sort of background music that I'm playing, which is actually from the Heartbound soundtrack, which is being developed by, it's a game being developed by Pirate Software. So he was nice enough to let me use some background music for the stream, just to kind of add a little something to it, if you will. And so I would say definitely give him a shout out, or give him a follow if you don't already follow him. He's developing a non-traditional RPG called Heartbound, and that's where this music is actually from. So there's a link to that, and a shout out to Pirate Software. You did hear the fire sound. I actually didn't turn that off. That would be this one here. Right? Oh. So this is event code button clicked. This needs to be event code mouse moved. And this needs to be the same thing. And now we should be able to see it. Yeah, they're separate sounds. Yeah. Okay, now we're getting this breakpoint. Okay, so let's do that. I still don't see a hover happening though. So I guess let's have a look. In fact, I'm going to set the breakpoint a little bit further down inside. Actually, it's not hitting contains point. Okay. Oh. Derp. I know why. Because we're only doing this if we have these callbacks set. But we actually should not be doing that. Because we're actually checking them down below. So we should not be doing that. That's why. That's failing because we don't actually have any user callbacks set. So it was never actually going into it. Lame. All right, let's try hovering again. Get rid of this breakpoint for a second. Okay, so we're still not getting a hover event. So this should definitely be interacting with it. Okay, so transform vector 2. Why is that such a big number? These are both... Oh, these are U16s. That's no good. Those numbers can technically be negative. These should be I16s, which is why I'm getting that weird number. Because technically speaking, like if you mouse outside the window to the upper left, you could get negative values, and we should probably have some logic in to handle that as well. Yeah, and we're even parsing them as I16s out of the event, but they were U16s, which is no good. All right, so I wonder if that's it. So let's run again. And I'm going to kill this for a second. Hover over in here. And yeah, that should be fine. So let's take a look at the event. Oh. This is another copy pasta problem. So, when we process the mouse move event, we do not have a mouse button to process. So this should be 0, this should be 1. Right. I'm actually thinking it'll work now. Yep, there we go. So we got hover working. And it even works with the button rotated. That's the reason this is at a 45-degree angle, by the way, is we're testing to make sure that that actually works. All you can eat at Olive Garden. This OST is awesome. Yeah, it is a really, really good OST. It's one of the best I've heard, actually. I'm thinking if I ever get to the point where I build a large enough game, I will probably contact the guy that did the music for this and figure out what his rates are, right? Because it's truly an amazing soundtrack. Okay, so we have hover, although it looks like our Y position might be a little bit off. It looks like we might be short a pixel in the Y position. So let's do 31 and 37. There we go. Perfect. That looks pretty good, I think. Right? Not bad. And so there's our button hover, and there's our click event, right? Right? And we can't click it when the button is shrunk, but we can click it when it's bigger, right? Okay, so we have hovering. That's cool. So the next thing that we need to do is we go back to this list here. So we have normal and hover. Pressed state would be good. So we can go ahead and put that in. And so I think we should be able to do that relatively quickly. Still using the VS Code debugger. Yep. Like it better than GDB or just more familiar with it? I find it faster to use. I am experimenting with a couple of other debuggers off camera, but I don't really want to fumble with that on stream, right? I just find this one a lot faster to use because I can quickly come in here and examine things just by kind of hovering over them, set breakpoints really quickly, and GDB is just not quite that user-friendly, right? But I've been testing a couple of front ends for GDB, which is really all this is just a front end for GDB. Like I've actually got, I have the ability in Vim to debug. So I do have it here, right? It's just this one, and again, this is just another front end for GDB. So I do have the ability to do it here. It's just not quite as clean. So yeah, I'm sort of researching different things. Okay. So we have our click state, but for the sort of pressed state, we're actually going to need one more thing, which is going to be basically very similar to this, but it's going to be specifically just for mouse down, right? So we're going to say mouse down. And I think for mouse down, we do still need buttons. I suppose we got to add like an on mouse down and an on mouse up too, right? So I guess we could do that simply enough. So on mouse down. And on mouse up. We don't necessarily have to implement these, but what we're going to implement is sort of the same thing that we did down here. Right, so we're going to say on mouse down, on mouse up. And I guess we'll go down here to the bottom. And get rid of the exports. And we're essentially just going to be editing the Atlas min and max again. So in this case, the X's are all going to stay the same. Let's look at our image again. So the press state is the one that we want. So it looks like we're looking at so 151.21 and 157.27. So 151.21 and 57. Right? I think that's right. And that's how we're going to handle our mouse down. And our mouse up is only going to happen if we're in a hovered state. So technically, we're going to apply this. And we're gonna clean this up and make it less repetitive, right? Where we can just call a function that just takes these. But for right now, this just makes it a little bit easier to deal with. So up here on the mouse down, if we contain the point, we're not going to do this. We're going to say standard UI system, actually SUI button, mouse down. Okay. And then we're literally going to have the same thing. Actually, you know what? Heck with it. Again, we will remove duplicate code after this. I just want to see it working for now. I was going to say we should extract this to a different function and whatnot, but I'm not going to worry about that yet. I want to just see it working, and then we can clean it up afterwards. So we need to register 2 new events. Standard UI system mouse down and mouse up, and this is going to be button. Do we not have if button clicked? There's a button down. What is it? Pressed and released. Okay. So this is going to be button released. Take these down here, put them in the unregister. I think that's actually all we need to do. So let's run this. And if we press down, right, obviously our image is wrong. So our points are wrong there on that one, but the restoration works correctly, so let's see. This honestly felt wrong, to be honest. These points. So 151, 21. Oh, no wonder. That's supposed to be 27, so 28. Where did I get 57? Okay. All right, so now we have our depressed state, right? Cool. So note that our click still works, right? We'll have to handle some edge cases, like what happens if you press down, drag out, and then release, right? That doesn't actually do anything, because we should be able to do this, right? But if we're pressing down, it should handle it accordingly. So there's some state issues there that we need to figure out. So I'm thinking probably the easier one to handle will be when we hover, we can check to see if the mouse button is down, I guess, and go from there. We may want to have... We may want to have like a pressed state. Maybe that pressed state stays active until we release the mouse, no matter where the mouse is. So on mouse up. Technically, the mouse up probably shouldn't even check bounds. Or maybe it should, and we just handle this differently. Let's see. Yeah, GDB is pretty Spartan. Yeah, I would agree with that. That's a good way of describing it. Been too lazy to poke around with other solutions. Yeah, so there's one called Seer that's pretty neat, and there's also GF2 that's pretty neat as well. So those are a couple that are available on Linux at least. For Weiroo, first time chat, so welcome to the stream. I've been watching your YouTube series lately. I'm not actually making an engine, but it's really fun to watch the process. Well, awesome. Well, welcome. I'm glad you're enjoying the series. That's awesome. How far in are you? Let's see. So how should we handle that drag case or something? We should probably figure out a way to handle that. Episode 20 or something. A lot to go. Yeah, there's like 147 episodes, technically speaking. I mean, this one is marked as 143, right? But there's like little mini ones in between too, like patch videos and stuff. Plus, it's 0 indexed, right? I started the series with episode 0 because we're programmers here, and 0 indexed is the way to go. But yes, that's awesome. Only 500 more to go to catch up with Handmade Hero. Yeah, well, you know, I can't work on it as often as he does, unfortunately, so, although I guess he's taking breaks, so there's that. Alright, so let me, I guess, try to figure out, yeah, we'll get there, for sure, yeah. Looks like I've actually missed a couple of follow notifications. Stato Aus, Avalanche Pointer, Mad Dog Santos, and Hatrick. And For Weir, thank you for the follows. I appreciate that. Thank you and welcome. Yeah, no problem. So, I guess let me try adding another state to this, which I'm really beginning to hate how many booleans we have here. This is a total waste of memory, right? Is pressed. And I'm going to put a to-do over this because this is really bothering me. Convert to flags. And then what we'll do is on mouse up. Oh, you know what? There's a problem with this. We're assuming that these are buttons. We can't make that assumption. So we're going to have to fix that. To do switch from B8 to B32? Ugh. Yeah. I mean, if I'm going to do that, though, I'll just use a U32 at that point. I mean, I actually do. So, I think I still have it in here. Yeah. I still have B32s in here. Namely, Windows is what uses it, right? But yeah, most of the time I just stick with 8 bits. I was using B32s for a bit, but I got away from that pretty quickly. Which theme is this NeoVim theme? This is add a Weta, I believe. Config and vim. Was it color scheme? Yeah, add a Weta. That's it. C23 bye-bye bool. I haven't read up on C23, but is that really a thing? Are they just making it bool instead of underscore bool? I've literally not read up on it at all, so I couldn't tell you. Okay, so we need to address this. Buttons. We need to address this for sure. So if we contain the point on mouse down, then we can say control is pressed equals true. If we have a mouse up at any point, even if we don't collide with it. Oh, this is... Why are we checking on click? We shouldn't be doing that. In either of these scenarios. So I guess here... we can always just have that not be pressed, no matter what kind of control it is, right? So we only press if we're actually inside the point, but we can unpress otherwise, right? So let me see. So we have mouse over if self is pressed. And then do one thing, otherwise we use the hover, right? So we'll use, let's do this. And then on mouse down, we want this. So put that here. So that way when we mouse out, but we're holding the button down, it's still pressed, and then we mouse back over it. If we're pressed, we should use this, otherwise we should use this. And then on mouse down is fine, on mouse up is going to be two different things also. So if self is hovered, we're going to do one thing, otherwise we'll do the default logic. Right, so the hover, we're going to want this. Oh, ads again. Okay, we'll pause the stream for a minute. Got about a minute left on ads. About 10 seconds left on ads. All right, and we're back. So really quickly, now if we hover over this guy and we click and hold down, right, and move out, it goes back to the normal state. I'm still holding the mouse button down. So now if we mouse back over it, we go back to the press state and mouse up. If I drag out and mouse up, then it works, right? So that actually, that's it. We have that edge case solved. Let's see. I was playing around with a GUI tutorial a while ago. I think the way they handled this was to keep track of the hot widget, the widget that the mouse is over, and the active widget, the widget on which the mouse down was pressed. And if the hot and active widget matched on mouse up, only then would the widget be triggered. Yeah, I see how that makes sense. That's one way to handle it. It was also an mGUI tutorial, so the widget state was global to the UI. Not sure how that would carry over to a retained GUI. With each widget keeping track of its own active state. Yeah, exactly. So I don't know. I mean, theoretically, you could have an application global tracker if you wanted to. Like, you could leave that up to the application to track. Like in this case, we don't actually get a click event. If I click and drag and then release, we don't actually get a click event. The only way we get a click event is if we mouse down and mouse up without moving the mouse, right? So that may be something that we want to address as well, where maybe for buttons, if we do mouse up over the button, maybe that also triggers it, right? As opposed to just a click. Because a click or a press down and a move is considered a drag, and once you have started a drag, you can't have a click. So that might be something to figure out in the future, right? But I think for tonight, that's actually pretty decent progress, right? I do want to leave a couple of quick comments here. To do dry, right? Don't repeat yourself. So we need to split this up into a function that just does all this stuff and just takes these in as parameters, but B, this should be stored as some sort of configuration for the button itself as to what these positions are, so that we could just reference those in code and not have to worry about these hard-coded magic numbers, right? So we just wanted to see stuff work. But now that we have things working, we need to actually go back and refactor that a little bit. We also need to get rid of this assumption that we're a button. So I'm going to have to think on how to do that in a nice generic way, and still retain the ability to have this generic function that runs, but also the user function that runs as well. So maybe that's two function pointers. I haven't really decided yet. The tutorial didn't get as fancy as drags. Yeah, and we already actually have dragging in our UI system. Like our, not our UI system, but our input system. So one thing that we use that for example, and the reason that we implemented it in the first place, is when we load up our level, right, and we have an object selected. Let me make this smaller so you guys can actually see it a little easier, maybe. Oh, you know what? I think me putting the UI in here is actually broken my ability to select an object. Because my UI is now eating the events, so that's an issue. But what I was going to say was the reason I put that in there was for the ability to interact with this guy, right? Our transform gizmo. So, and I think that's actually, you know what? That might be a quick fix. I think I just need to return false on these to say they're not handled. System move. That's gonna be another one. Glad I caught that, because that would have really confused me later. Just make sure that this works again. Yep, there we go. Okay. So, yeah, now I can select the car. And, yeah, the reason that I had the drag in there was so that I've got these hover states on this gizmo, right? And I need to be able to drag this and move it, right? So I needed a way to be able to tell, am I just clicking something, like to select the car or the big spawns of mesh back here, right? Am I just clicking something or am I actually dragging it to move it? All your event are belong to me UI. Yes, exactly. Anyway, so that is going to actually do it for the stream tonight. I am going to take a quick look and see who's on that I can raid. I am actually going to raid Jitspo tonight because he's doing a retro FPS that is a really cool looking project. So I'm probably going to raid him. Before I do that though, I want to go ahead and just drop all my social links, so prepare for some chat spam. Just like my Discord and Twitter and all those various things that we can that we all have to maintain, right? All the various places to follow me on. So yeah, thanks for the stream and breaking during the ads. Yeah, no problem. That's kind of a thing that I like to do. It just, you know, kind of respects the people that are trying to watch it and understand what's going on, right? So I try to do that. Thank you for the feed, cup of coffee. I hope I pronounced that right. I'm assuming that from the spelling of your name, it's coffee. Cool. So let me go ahead and check out his channel. And yeah, we'll go ahead and raid Jitspo. He's working on a retro FPS, so his project's really cool. And I would say ask him to throw a book, and you'll see what he means. Because ask him. Actually, I would say ask him what features in his game currently interact with throwing a book at it. And that's an awkward way to ask it, but I guess you guys can probably word it better than me. But anyways, we're going to start rating him. He's got a really cool looking project, so I definitely recommend you guys check it out. And yeah, I think that's going to do it for tonight. So thank you guys so much for joining me here. And I appreciate you guys, and I'll see you on the next stream. See ya.